So this is a video about structs. So sometimes you have a bunch of variables that just sort of naturally go together, that they describe just one thing. Like an example that comes to mind is like a pixel. You know, a pixel is 1 byte to describe the amount of red in the pixel, 1 byte to describe the amount of green in the pixel, and then 1 byte to describe the amount of blue in the pixel. So if you want to talk about a pixel, um, it would be nice to be able to deal with it as just one data type. And other languages that you might be familiar with have ways of doing this, like C++ and Java. And actually, if you know those, you probably already know about structs. But what about something like this? You can see that compiles if you spell struct correctly. And you can do something like this. So this is a way of just keeping track of all this data that relates to sort of one thing that's naturally just one thing, information relating to a pixel, to kind of encapsulating it and wrapping it up and letting you treat it like just one thing instead of keeping track of a bunch of variables separately. You could keep track of all these variables separately, and just every function that you wrote, you could pass in these three values, and you could be really careful to keep everything, organized. So it's just a convenience. You could do without it, but it makes life much nicer. And you can initialize these things just like you would initialize an array. So there needs to be some value for the red content, and some value for the green content, and some value for the blue content. So in this case, would produce sort of a grayish pixel. And so when I define an instance of this new data type, which is a color struct, it's kind of irritating that I had to write these two words. This is just sort of an aesthetic thing, but it would be nicer to just write one thing. And so that's what this next line is about. So this is type def, and it's just a way of establishing like an alias or a synonym. So this is saying that I'm now going to use color T as shorthand for struct color, and it just looks a little bit better. And so you could do pixel 2 is equal to 0 and 0xff or whatever. Okay. So now this second variable, pixel 2, it's of the same type as color T, which is really just a struct color. So we're talking about the same thing every time. And so let's do some things with this. Maybe let me turn this off for just 1 minute. And so something you might want to know is how many bytes that thing takes up, right? And what does it look like in memory? So let's do a ZD, and we'll look at the size of color T. And so what would you expect the answer to be? So it uses 3 chars, right, which is 3 bytes. So you'd expect the answer here to be 3. And it is 3. Sometimes, though, the compiler will insert padding in here, and so there will be some unused bytes possibly. There's something you could turn on, which I have turned on here. It's the pack pragma. So pragma is advice to the compiler about preferences you might have for things that aren't defined by the C standard. So it might be that I want my structs to be packed as contiguously as possible with no wasted bits, and so that's what the pack pragma tells it to do. In this case, it's not necessary because, well, how do I know it's not? Well, I was playing with it earlier, and I know that it's 3 no matter what. But maybe you can try to make up an example where, what if I do, I don't know, if I type like long H in here or something like that. Let's see if we can break something. I'll get rid of these so I don't get a syntax error. And let's see. So now it says 24. Does that make sense? So this is 8 bytes and then 3 more bytes. That seems like 11. I wonder why is it saying 24? Um, so I can't come up with a good reason why it's saying 24. So let's turn the pack pragma back on and see what happens. And now it still says 24. Am I just being stupid? What is a long? Long is just 8 bytes. So this is 1, and then 8 is 9, 10, 11. So I can't tell you how it's getting 24. To figure that out, we would have to get out the debugger, and maybe we can do that in a different video and try to understand how that works exactly. But all right, so you can see that I've defined another struct here, just to give another example. So something you might use a struct for is to represent like a row in a database. Maybe you're making some kind of database of boxers and you want to record their heights and reaches and wins and losses and their names and their weight classes and their coach and stuff like that. So what I've done here is I've combined sort of these two things. So this declares the struct and then you do the type def. But you can do both at the same time, and you should parse it like this. This is saying the stuff in gray here is going to be a synonym for this, and this is going to be the boxer type. And I do underscore t as a naming convention that some people use to remind the user that you're talking about a type and not a variable. So it might be that there's some variable called boxer and you don't want that to be confused with the boxer type. You couldn't possibly confuse them using Genie because of the syntax highlighting. Syntax highlighting makes these bold blue because it knows that they're types, but if you're using some other kind of IDE, maybe it's not as helpful. All right, and so here, just to give an example of how you might use those things if you're writing your own database application, an array of boxer structs is a database with 100 entries, and you could even make this sort of dynamically allocated if you want. Or maybe you don't want to use an array, you want to use some other more complicated data structure that we haven't talked about, like a binary tree or something like that. Okay, and so let me make this main again, now that we've looked at this memory usage stuff. By the way, something that's kind of interesting is that the boxer is packed tight. If I change this to boxer t, I get 96, which you can check is the minimum possible number of bytes that this thing uses if you add all these up. So kind of interesting. But anyway, coming back here, so I've got a color and some boxers, and I was talking about the gem. I'm not actually going to use those to do anything. But let's just stop the program right here. And so what am I trying to show? What I'm doing is I'm experimenting with using assignment equals and structs. So here's a struct, blue, and here's another one that hasn't been initialized. And what happens if I set these things equal to each other? So you don't get a syntax error. It does complain that I haven't included standard lib, and so it doesn't know what exit is. Okay. And so that's a lot of F's, isn't it? This is a problem that I sometimes have, and I can't always replicate it. But is this, what if I do XX? H, no. There's something you can do, is it like, is that the one? No. There's some format that you can use for doing hexadecimal with chars. Sorry, I'm such a bad teacher, but you can see that this is way too many F's. It's because it's printing this thing as an int instead of a char, and there's some, maybe I could just pause this video and go find out for you really fast. Okay, the thing that I was groping for, I found it is, it's HHX. And you can see here that that got rid of the extra F's, and so you really get just the char and hex, which is what you would want. So, alright, why were we doing all that in the first place? We were trying to see if assignment equals actually worked, and it did work, because this is just random garbage. I could even initialize it to be something else, like oxdd, 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 and all that would be overwritten on line 44 where I do the assignment, and I took out the exit, so it's talking about Freddie Roach, which is probably blowing your mind. Okay, and right, so it overwrites these values and gives you the it makes the pixel blue. But that can you can it doesn't always work. It makes what's called a shallow copy. So what it effectively does is it says something like c dot r is equal to blue dot r, and c dot g is equal to blue dot g, and c dot b is equal to blue dot b. So this assignment equals is shorthand for just setting all the fields equal to each other independently. And you think, well, isn't that just exactly what I wanted to do? The problem comes when you have structs that have data types that are not suitable for use with assignment equals. Like you can't just set two arrays equal to each other. Here, let's try to do it. What if you do int a is 5, let's say just two ints, which are 0 and 1, and then um, you declare another array of length 2, which is b, and then you do b is equal to a. So you might find it kind of shocking that the language C is so trivial that it doesn't understand what you mean, but it doesn't. You can't do this. If you set arrays equal to each other, if you don't get a syntax error, you'll probably get behavior that you don't anticipate. So it just doesn't handle that kind of thing. What you have to do is write some method that makes them equal to each other and copies every entry. And that's what I've written this function for, and I'll get to that in a second. So just experimenting with the boxer, the boxer has some of these array types, and so you'd expect that assignment equals wouldn't work as well for a boxer. Here I've got this boxer named Clyde, and I have his information typed in. This is supposed to be in meters if you care, if you're a boxing fan or something. This is some generic dude, and when I do the assignment equals, we can look and see what happens. And let's just, let me exit the program there and let's see what happens. Okay, so it actually comes amazingly close to working. This is what happens when you try to print out. The problem is Boxy's name has, it kind of copies, but then it's got this garbage at the end, and then this is right and this is right. It's misleadingly right. You can't do this or you'll get big problems. What you have to do instead is write a program that does the copying, right? And I'm sending in pointers, and when you send in memory addresses, you allow the possibility for changes in the function to affect the variable that you're passing in, and that's exactly what I want to happen here. Actually, I could make this one const if I wanted to, and that would be good practice. That just means that's a promise that the value of that one will never be altered inside the method. And that's because this is the source and this is the destination, and only the destination needs to change. Up here in my prototype, I need to say that it's const there too. And now if you do try to modify what's happening in B, now you'll get a syntax error. But since I don't do that expected expression before const on line 55, right, so somehow, oh, you don't have to write it there, just in the prototype. Right. Okay. So now it's run the entire program, and you can see that after I do the box copy method, they really are the same. These two lines are exactly the same. And all the other information has been copied too, like the information about height, weight, reach, etc. So let's look at this box copy method. So it takes two pointers to structs. And when I was an undergraduate, my professor would have yelled at me if I created a method that took a non-pointer struct as input. Like let's just say that I have some foo, and it just takes a boxer t as input, and then it goes on, to do something with the boxer type a. What are you doing here? You're passing in 96 bytes, and that takes time. It's inefficient. But this is just a memory address, so this is like 6 bytes. Here you have 6 bytes, here you have 96 bytes. This one's going to make a local copy of this thing, and it's going to slow down your program if you have a lot of instances of it passing in 96 bytes. It's kind of a lot to copy. I think the compiler is smart enough now that it just does this for you automatically. Certainly if you turn on some of the optimization flags, it would do that for you. Um, and it's really, sorry, it's O instead of 0. So this is optimize level 3. And if I optimize level 3 and then I get out the debugger, I am fairly confident that I would find, if I could figure out what was going on, that it had converted everything to pointers for me. But it doesn't look that bad. It looks natural to me, and so I don't see any reason not to just go ahead and do it this way. Plus, we have to do it this way in this function because we want to modify a, and so we need a pointer. So I just set all these things equal to each other. Here I'm just being kind of extra careful. If I just did a equals b, it would probably take care of this stuff for me, but I'm being, good. And now we do the string copy for the others, and you're saying, can't you get buffer overflow attack or some other thing like that? Yes, if somebody wanted to infiltrate my boxing gem using some kind of super cyber hacker technique, I would be vulnerable to that because string copy is an insecure function. But I'm not really worried about that right now. Another thing is, there's this weird difference between a pointer to a struct and an actual struct. You can see up here, when I'm talking about a struct that is just a struct, C is just a color T, it's not a pointer to a color T, then I use the dot notation. But when you're talking about a pointer, you have to use this arrow notation. And I don't have a deep explanation for whether it's true. I guess you want to, keep the two separate. But you have to keep in mind that you have to use the different notation. And sometimes you can forget about this, and the compiler can give you a completely unhelpful error, and you don't know what it's saying. It's saying request for member height and something not a structure or union. Very useful error message, right? Not have no idea what it's talking about, but it's talking about that. And so that's it. Structs are extremely useful, and we'll give some applications and some videos to come.